Get ready for a mind-bending journey into the cosmos. We're about to dive into some groundbreaking discoveries that might just change our understanding of the universe. The recent observations of two extraordinary black hole collisions have left scientists buzzing with excitement and intrigue. The international LIGO-Virgo-KAGRA Collaboration has unveiled two record-breaking events in gravitational wave observations detected in October and November 2024. These events are like cosmic clues, offering a glimpse into the mysterious ripples in space-time and the powerful forces that create them. But here's where it gets controversial. These observations might just challenge our current theories and open up a whole new realm of possibilities. In the last decade, since the first detection of gravitational waves, we've witnessed hundreds of these waves, each produced by the incredible collisions of dense objects, neutron stars, and black holes. But these two new observations are like nothing we've seen before, and they might just represent a paradigm shift in our cosmic exploration. Let's start with GW241111, detected on October 11, 2024. This event involved the collision of two black holes, one around 17 times the mass of our Sun, and the other a mere 7 times. What's truly remarkable about this collision is the spin of the larger black hole. It was spinning at an incredible speed, reaching around 75% of the theoretical maximum. Imagine the power and energy released during this merger. The second event, GW241110, also involved black holes of similar masses, around 16 and 8 times the mass of our Sun. But the peculiarity here lies in the direction of their spin. Usually, black holes spin in the same direction as their orbit, but in this case, the larger black hole was spinning in the opposite direction. A truly unique and mind-boggling observation. These two record-breaking events suggest that the larger black holes might already be the result of previous black hole mergers. In other words, we're witnessing second-generation black holes, which is an incredible concept in itself. But it also tells us something about the environment where these mergers take place. It's like a cosmic dance where black holes merge and create new, even more massive partners. Professor Stephen Fairhurst, a spokesperson for the LIGO scientific collaboration, emphasized the novelty of these events, stating, GW241011 and GW24110 are among the most unique events we've observed. With one black hole significantly more massive and rapidly spinning, they provide tantalizing evidence that these black holes were formed from previous mergers. Gianluca Gemmi, spokesperson for the Virgo Collaboration, added, "These detections showcase the incredible capabilities of our global gravitational wave observatories. The unusual spin configurations challenge our understanding of black hole formation and offer compelling evidence for hierarchical mergers in dense cosmic environments." But here's the part most people miss. These observations have applications beyond just black holes. They allow us to test our understanding of particle physics and general relativity. The team measured these events with such precision that they could conduct tests on hypothetical particles, like ultralight bosons, which might explain dark matter. And for general relativity, they searched for effects beyond Einstein's theory, finding good agreement but leaving room for further exploration. This discovery enhances our sensitivity to any new physics beyond Einstein's theory, explained Carl Johann Haster, an assistant professor of astrophysics and co-author of the paper. It's an exciting time to be a scientist as we continue to push the boundaries of our understanding. These discoveries, published in the Astrophysical Journal Letters, highlight the importance of international collaboration and the power of precision measurements. So, What do you think? Are we on the cusp of uncovering new cosmic secrets? The universe is full of surprises, and these observations might just be the key to unlocking them. Let's continue the conversation and explore the endless possibilities together.